We are now going to solve a very famous problem. It is called the Tower of Hanoi, and it is different from the problems we have seen so far because there is no strict mathematical formula that we can just take and translate into Java code. We need to work a little bit harder in order to think of the recursive solution to this problem. It's a very interesting problem. Let's take a look at the setup. In order to understand better what this problem asks us to do, we have used the particular website you see on your screen. You also see the URL. You can also find the URL at your notes at the slides. We have 3 pegs and 1 tower of n disks. In this particular example, you will see that n is equal to 5. We have not stacked the disks in a random order, but we have stacked them in order of decreased size. Every disk has a different diameter, and we have stacked them so that as we go down, the diameter increases. What do we want to do? What is the problem here? We want to move all of these disks from one peg to another. So we want to end up with exactly the same picture, but instead of having all of the disks on the very first tower, we want to put them, say, on tower 3. There are 2 rules, however, that we need to follow strictly. What are those? Only move one disk at a time, and no disk can be put on top of a disk with a smaller diameter. These are the 2 tasks that are going to make our life harder, and in order to understand better how this should work, let's run the animation. Let's start with a smaller size and try to see how one can solve this problem, and pay attention to see how the 2 rules are followed. Here the automatic solver did that in 7 moves. Let's see how that would play with 5 disks. You see that at any given time we always have a disk with a smaller diameter on top of a disk with a bigger diameter. At no time we have the opposite. How can we find the algorithm? How can we find out how to solve this problem in a recursive fashion? Here is how we can think about this problem. Suppose that we have to move a stack of 7 disks from A to C. Let's say that we have a way to move 6 disks wherever we want by some tool, some magic. So with this magic we can move a block of 6 disks from A to B. We would have to use 6. Then what we would need to do is move the 7th disk from A to C. And then again we would have to move the block of the 6 disks from B to C using A. This magic that is happening here will be the recursive calls. Let's take these lines that we just said, the move lines, and write them into a code format. You see that the first argument that we're going to this move disks method of ours will be the number of disks, and then we're going to say from, to, and using which one of the pegs. Then we will move with the same method the 7th disk, so we want to move 1 disk from A to C. So you see that we have changed the position of the pegs according to what and to where we need to move to and from. All we are doing now is filling in the blanks. So we will provide to this move disk method the number of parameters that we need based on the way that we have coded this move disks move. And we are also taking care of the base case, which is when we only have 1 disk to move, which, for example, when we're moving the 7th disk. Other than that, we're just calling from the main method the move disks the very first time, which will be when we have the total number of disks. In this example, you see four disks. What we have done here is just move to the IntelliJ environment with exactly the same code, and we have run the program. And what I would like you to do as an exercise, so that you make sure that you understand what's going on, is see the lines of the output and figure out exactly which recursive call produced them. In other words, try to run this program on a piece of paper and figure out its output, and then compare to what you see so that you make sure that you understand exactly which line is due to which method call.